So good morning, everyone. I hope my voice is audible to all of you,
Yes, sir.
and you are also able to see the screen. Okay, so good. We welcome you all. I and Akanksha welcome you, every one of you, to this introductory session on a new course that we are starting. And this is basically a course that we are starting on design and detailing of an RCC building for earthquake loads. Okay, using ETABS plus manual methods. So this is the course that we are beginning with. I hope you are able to see the slide on your screen, everyone. So we will just begin with our presentation. We have a small presentation that we have made outlining the course content and the details of course. Okay, so we will just run through this small presentation for the next 30-35 minutes, and then we will be here to take your queries regarding the course if at all you have any. So this is how we plan to move ahead today. So let's start. So this is the agenda of today's session, what we intend to do in today's introductory session. So we will start with what is the need for this course, why did we think that such a course should be uh, taken. Then we would be telling few things about our firm, about us, we would be telling. Then how this course will flow, what things would be included, what things will not be covered, that we will go to. Then there would be some general guidelines and instructions for the prospective students. Then how to proceed ahead, and in the end we will take all your queries that you may have. Okay. So this is how we intend to move ahead. Okay. So is the screen visible to everyone? All right. I think it is visible. Okay. Yes. Good. So first of all, we will start why and how did we think that such a course should be planned and it is relevant. So I hope many of you are postgraduate engineers, many of you are practicing consultants and working professionals. So you must have come across lots of things about earthquake and earthquake detailing and the importance of it. So, as you know, that around 40% of our land area lies in a seismic zone that is above 3. Okay, so seismic zone 3 means that your buildings are susceptible to moderate to high level of damages. Seismic zone 3 onwards. So, around 40% of land area uh, lies in seismic zone 3 and above. But if you see population wise, okay, if you see the population distribution, then you will find out that around 60% of population lies in a seismic zone that is 3 and above. Understood? So if you just have happened to see the seismic zone map of India, then you will find out that the entire northern plains lie in seismic zone 3, 4, and 5. The northeast, complete northeast portion lies in seismic zone 5. Your plains of Gujarat, your Western Ghats, they also lie in seismic zone 3. Some portions lie in seismic zone 4. So, population wise, you will see that the most populated parts of India lie in a seismic zone that is prone to moderate to high level of earthquakes. Okay. Then this is one thing that is problematic. The second thing that is problematic is that there is a presence in India of large number of non-engineered structures. Okay, so you see that in India there are lots and lots of structures that are non-engineered. By non-engineered, I mean that they are not being done by a qualified engineer. They are just being done on the basis of some thumb rules or on the basis of just some assumptions. So they are basically non-engineered structures. So there are lots of structures that are non-engineered in India, which uh, actually have a greater risk of failure during earthquakes. Okay, so this is the second problem that we always face. So let's imagine an earthquake that may come in Delhi, or that may come in some northern city of India, that will lead to catastrophic damage because of the high volume of non-engineered structures that are being built. Okay, and they are being built since a long time. I mean, it is not like that we have started constructing illegal or non-engineered structures just now. They are being built since a long time. So this is also a great risk that there are lots of non-engineered structures without regulatory, I would say, approvals that are being constructed. Then earthquake is a probabilistic event. It is a random event. You cannot predict what will be the magnitude of the next earthquake, and there is always a chance that the next earthquake may be the highest earthquake that is ever recorded. Okay, like in Gujarat earthquake during the 2001 earthquake that had struck 26th of January 2001. That earthquake had an acceleration of 0.3 g, around zero point 0.3 to zero point 0.4 g. Okay, which was much higher than what we designed for. So you cannot predict what will be the magnitude of any earthquake that is going to hit, and there is a real chance that the earthquake may surpass all the previous magnitudes of earthquakes. Okay, so there is always this risk. So due to these answer, and there is also a limited understanding that we have related to earthquake, because it is such a probabilistic event, and it is such a random event, and it is such a rare event that the complete understanding of earthquake is still not, I mean, we do not completely understand the effect of earthquake and its behavior. So uh, what our courts try, to I would say incorporate these uncertainties into some design and detailing aspects. Okay, so whatever these uncertainties related to earthquake are, our code somehow try to incorporate those uncertainties into load calculation and into design and detailing. Okay, so therefore, what I believe that these codes should be carefully and carefully studied, and they should be implemented well in your structural design. Understood? Because of these problems related to earthquake, what are the problems that I highlighted? That one, uh, there are, I would say, the earthquake behavior is not very well understood. So whatever limited information or whatever limited understanding you have is on the basis of around 10 to 15 earthquakes that have struck in the past. Major earthquakes I'm talking about. Okay. So maybe 10 to 15 or 20 major earthquakes that have been struck in the past. We have developed a complete branch of engineering on the basis of that. So the real understanding or the absolute understanding is still absent, I would say. So the codes, international codes also, Indian codes also, what they have done, that they have tried to formulate a strategy on the basis of this limited understanding. So we as a designer should also try to implement these codes, because of the unpredictability of earthquake and because of the lack of understanding. So we should trust these codes, and we should try to implement them as far as possible. Understood? Then implementing these codes and understanding these codes has another problem. What is this another problem? That these codes have been recently revised. If you have come across or if you have come across this, then you must be knowing that these codes have been recently revised in early 2017. Okay, so both the IS 1893. So IS 1893 is your code for load calculation due to earthquake. Okay, so IS 1893 is code for earthquake load calculation and general provisions. There are five parts basically to IS 1893. So we would be focusing on IS 1893 part 1, that is earthquake for general buildings and general provisions. Okay, so we would be doing that. So IS 1893 is your load calculation code, and IS 13920 is your ductile design and detailing code. So you can just for the basic understanding, you can understand like this, that IS 1893 is the code for load calculation, earthquake load calculation. And then you have got this another code which is called as IS 13920, which is for design and detailing. Okay, so we have on one aspect of earthquake is to be able to calculate the load, earthquake load, and its effect. And the other aspect is to design and detail for this earthquake loads. So basically, we would be studying both these codes. And in in the year 2017, both these codes were simultaneously revised. So in 1 year, both these codes were revised, and some major changes have been introduced in these codes. So even the new version of STAD, because if you are using STAD, let's say if you are using STAD Connect Edition, then the Connect Edition has incorporated these codal changes. But if you are, let's say, using STAD Pro V8i series, then even the software has not been able to incorporate these changes. Okay. And then our code also is not very clear on some new changes that it has introduced, and there are no solved examples as such, and there are no much I would say enough books being published till date which highlight these changes. Understood? So due to this, the new code understanding or the new provisions that have been introduced in the code are still not very well understood by the engineers. So therefore, understanding these codes become all the more important. So therefore, we thought about taking this course because of these two things. That first, earthquake effect in itself is not properly understood because of the inherent unpredictability of earthquake. So following code becomes important for us. Whatever limited knowledge we have about earthquake, we have it from the international codes or Indian codes. Okay, so this is the first aspect, that you should be following codes. I would say in a very strict manner. And second is that code in itself is difficult to understand. Okay, the code in itself is difficult to understand due to lots of changes that have been introduced. So therefore, in this course, we will try to, first of all, we will try to understand these codes. We will try to understand how earthquake load can be calculated, how that earthquake load is to be applied on buildings. Okay, what are the effects that we need to discuss or that we need to check for earthquake loads? That is the first aspect that we would like to cover in this course. And the second aspect would be how to design and detail for this earthquake loads. Okay, so earthquake load calculation will be done by IS 1893, and the design and detailing part will be done by IS 13920. So in this way, during this course, we will try to emphasize on both these codes. We will try to do it manually also. Plus, we will try to do it on ETABS also. So if you are using any version of ETABS other than ETABS 18, okay, if you are using previous versions of ETABS other than, of course, ETABS 18, then the new codes have not been incorporated. Understood? So if you want these new codes to be incorporated in your ETABS, you have to use ETABS 18 and above. Okay. So the new 2016 revised codes have not been incorporated in ETABS 2016 and in ETABS 2017. So you have to use ETABS 2018 if all these changes have to be I mean, if you want your software to consider all these new codes, then you will have to use ETABS 2018. So even the softwares are still in the process of revising, or the software in itself is in process of updating itself for these two new codes. So ETABS 2018 has these two new codes, and STAD Connect Edition has included these two codes. Understood? So we would be trying to do these things on ETABS 18, basically because ETABS gives you better outputs in the terms that it is able to calculate all the effects that have been included. Your STAT is not able to calculate all these effects in a proper way. So ETABS 2018 we would be using. Okay. So this is how we intend to proceed. I will just briefly tell you what are the major changes that have been incorporated in new IS 1893 and in new IS 13920. I will just tell you. So I hope you understand what is the need for why we thought that this is a useful course to be held, because of these two basic aspects. Okay, that one is earthquake in itself is not properly understood, and the second is that the codes which have been given by Indian standards, they in itself are also not very well understood, and therefore not well implemented. So uh, we would like to focus on these two aspects: load calculation, earthquake load calculation, and then design and detailing for these earthquake loads. So these would be the two major aspects that we would be covering during this course. Understood? And as practical engineers, because we are practical engineers, we are practical working professionals or postgraduate students who want to be structural designers or who want to work in this field, we would be focusing more on design and detailing rather than the analysis part. Okay. So let's say if you are doing your post graduation degree, you must have heard about these words as non-linear analysis and pushover analysis and time history analysis. So all these are types of analysis. Okay. So finally, at the end of the day, as a structural designer, what do you need? And as a structural designer, you need to understand the design and detailing aspects. So analysis is of course one part, but the structural designer also needs to understand the design and detailing aspect more. Okay. So during our education we focus on the analysis part more, but as a working professional or as a working designer you need to focus on design and detailing aspects more. So during this course also we would like to focus more on the design and detailing aspect, so that you should be able to apply this knowledge in your actual project. Understood? So this is how I intend to proceed. So I hope you now realize why this course is important. So just a basic introduction about our firm. So we are structural consultancy firm, and we have been doing work since 1995. So I am not that old, but our company is this old. We are involved in industrial works, design works. We are involved in design structural consultancy for residential commercial projects. We do lots of warehousing logistics projects also. We have done repair retrofitting projects also, forensic engineering, project management consultancy. So these are the broad, I would say, broad verticals under which we do our work. Okay, I will just take a 1 minute break because there is some external sound that is coming. So I will just take a 1 minute break. Okay. Yes. So okay, continuing with our discussion. So these are the broad verticals that we work in, which you can see: industrial designs, commercial residential designs, warehousing logistics, repair retrofitting, project management consultancy, and all that. Okay. So then in year 2015, along with this consultancy, I and my wife also started taking these training courses. So under this AuxEn, we started doing these trainings and all that since 2015. So we have been doing both these things of training as well as consultancy. Okay, and we have conducted several courses during the past 4 5 years. So we conduct RCC courses, we conduct structural steel courses. Then we have also conducted seminars, workshops at various locations in Indore and few outside Indore also during the past years. So these are some of the consultancy projects that we have. Just some pictures I have put here, and then these are some pictures of the. These are the offline sessions that we used to conduct earlier. So if you see, these are classroom courses that we covered earlier. Then these are some technical lectures and seminars that we have conducted. Uh, yes, then many of you are past online students. I mean, many of you are past students who have attended some online courses with us. So we started taking courses after this pandemic situation. So in the last 3 months, we have taken around four. We have completed four courses till date, and we have got a very good, I would say, enthusiastic participation from participants across India. Because of the geographical advantages of going online, we could tap participants from across the country, from the length and breadth of the country. Plus, we had some participants from some Middle Eastern countries also. So we have had a good number of students in the past courses, and we have got some very good and positive feedback from the participants. So which has basically put a lot of enthusiasm in whatever we are doing. So it has, I mean, inspired us to even do more and try to introduce more and more new courses for the benefit of students at large. Okay, so this is how we have been taking courses. So these are some few pictures. This is the same whiteboard that we use. So if you see the pictures, we are taking these courses, and these are some feedback that we have received for the courses that we have completed. So I think few of the students whom I have mentioned over here are also attending today's session. So these are some uh, good feedbacks that we received from the participants. So I've just put them here. Then this is about us. We two of us would be involved in taking your trainings. So I am Ashutosh Kutumble, and I have done my engineering from Indore GSITS and MTech from IIT Roorkee in 2011. Then I worked for around 2.5 years at a multinational consultancy called Dar Al Andasa Consultants. So that was at Pune. So I worked for around 2.5 years at Pune. And then in 2014, I came back to Indore uh, to get associated with our consultancy. And then since 2015, we have been, me with my wife, we also started doing these trainings. So since 2015, we have been doing trainings as well as consultancy. Okay. And then on your left, you will see is Akanksha. So she is my wife, and she also is a postgraduate. She has done her graduation from Kota, Engineering College Kota, and she has done her MTech from IIT Roorkee. And she also worked in Acon Consultants. Then she worked in Dar Al Andaza Consultants. Uh, then she, I mean, we both of us came back to Indore in 2014. And then you know the rest of the story that we have been involved in trainings and consultancy since then. So we both of us would be involved in the course. Uh, so I will like to call Akanksha to just say a few words to all of you.
Hello, hi. Welcome all of you. I'm Akanksha. Ashutosh has already introduced me. This will be our sixth online course. We both will take care of all your doubts and we both will make sure that no doubt is unresolved after the session. And you can ask any of your doubt after the class as well. After the session is over, and you can ask all your doubts. So I hope to see all of you in the class. See you soon. All the best.
Yes, so thank you. Then we will quickly, right. So this is an important slide that we have, that how our course will flow and what are the basic inclusions in this course. Okay, so very important to understand. So please have a look. So the things that we would be included would be IS 1893 2016. Okay, so IS 1893 2016, as I told you, it is a code for basically load calculation, earthquake load calculation. Okay, so it has 5 parts. IS 1893 has 5 parts. We would be discussing part one, and part one would be focusing on the general provisions and load calculations and provisions for buildings. So that is how your part one is described as. So under IS 1893, we would start with understanding of what is a lateral load resisting system. What do you understand by a lateral load resisting system? Then we will try to understand what are the earthquake parameters. You must have heard these words: zone factor, response reduction factor, importance factor, time period, spectral acceleration. So all these parameters we will try to understand. Then we will try to figure out how the earthquake loads is calculated, what is meant by base shear, what is meant by overturning moment, how your base shear is calculated, how it is distributed uh, across the floors. So all those things we will try to calculate, we will try to understand and calculate also. Then we will try to understand about an important aspect, that is regularity and irregularity in your structures. So we'll try to understand about regularity, irregularity, and the I would say the design aspects of regularity, irregularity, and what it leads to basically. Okay, so we will discuss that. What are the what is the mathematics that is associated with this regularity, irregularity? Then we will study about the proportioning of your building for earthquake effects. So we will study that, and then we will discuss about the design, not design aspects. I would say I would like to call it as the analysis result of these earthquake loads. Okay, so the analysis results would be, let's say, your bending moment, deflection, shear force. So what are the limits on these analysis outcomes of earthquake forces? We will try to calculate that. Okay, and of course you're proportioning for earthquake effects. So these are all the aspects that we would be covering under IS 1893. So IS 1893, as I mentioned earlier, is your code basically for earthquake load calculation. Once you have your earthquake load calculated, and once you have your design actions in front of you due to these earthquake loads, then you move to what is called as design and detailing for these earthquake loads. So the design and detailing code for earthquake loads is IS 13920. Okay, so that is ductile design and detailing. And as I told you, after 2016 revision, earlier this code was only called ductile detailing. Okay, earlier this code was only called as ductile detailing for structures subjected to seismic forces. But now the name has changed to ductile design and detailing. Okay, since 2016 revision, the name has been modified to ductile design and detailing. So they have included a number of design provisions also, which were earlier absent from your 93 revision of this code. So what are the design aspects that have been included in this new code? So we would study that. We would study how to proportion your beam and column and walls and everything in your ductile buildings, ductile frames. Then we will discuss about the ductile design and detailing of beams and columns. We will discuss about beam column capacity design. So this is a new clause that has been introduced in the 2016 revision, which was not earlier present. Then we will discuss about joint shear. I mean, for all these, we would also be solving problems. We would be doing this manually also, and I would be showing you how ETABS is doing this. So we would be doing it both ways. Okay. So we would be doing this joint shear design, and we also would be doing the shear wall design. Understood? So what are the methods that are given in your IS 13920 for shear wall design? That also we would be discussing. So I think this is a pretty complete course, I would like to believe, and it is a comprehensive course which covers almost all the important aspects related to earthquake load calculation and design and detailing. I would not say it covers all the aspects, but I would like to say that it covers all the important aspects that are that need to be understood by a practicing design engineer. Okay. Uh, so these are all the things that we would like to cover over here. Then the things that I would not be covering would be your time history analysis, your pushover analysis, response spectrum analysis. Also, I would be introducing, but I would not be covering in great detail. So analysis part, as I just told you, that I would not be focusing more on analysis part. Okay, because many of you are postgraduate students. So as postgraduate students, you must have been studying lots and lots of analysis related to earthquake effect. So I think you must have worked on time history. You must have worked on pushover. But let me tell you one thing, that in practical projects, the design engineers do not understand about time history and pushover. Okay, so they are mostly happy with doing your equivalent static method and in some cases response spectrum method. But as a design engineer, the design engineer is more interested in the actual design and detailing of your RCC building. Okay, so therefore I also would be focusing more on the design and detailing part rather than an analysis part. As a student, you are more focused on the analysis part, which you actually do not get to use more. I mean, which you do not get to use much during your actual practice career. Understood? So similarly, we also would be focusing more on the design and detailing part, which is, I think, more important from a practical viewpoint. So so I would not be covering time history or pushover or response spectrum. Response spectrum, I would be introducing to you what is meant by response spectrum, but I would not be covering it in great detail. But time history and pushover we would not be discussing, and we would not be discussing design of foundation system. I will only tell you the detailing aspects of foundation that have been introduced in IS 13920, but not the design part, because design in itself will mean that you need to understand the substructure design independently. So we would not be covering the footing design as such. Uh, I would be telling you the detailing clauses. Okay. Then this is a slightly, I would say, uh, I would like to call it that this is slightly a second level course. I mean, this should not be taken by students who are not clear with basic RCC designing. Okay. So I would like to call it as a slightly advanced level course where we are discussing the earthquake effects and earthquake load effects. So if a student is starting from the very basic, let's say, if a student does not understand the basic terms related to RCC design and detailing, then they should not take this course, I would recommend, because this would be, I mean, when we would be discussing things, we would assume that some basic level of RCC designing is understood by the participant. Okay, so I would not be discussing on the basics of RCC beam and column design. We would be assuming that as a participant, you have some clarity related to basic RCC designing. Okay, so it is expected that you know this. Then this course will be a blend of online teaching, I mean online as in teaching on software as well as teaching on board. So we would be in a way mixing these two techniques, board teaching as well as uh, software teaching. Okay. Every session we would be having doubt sessions at the end of lecture so that all your doubts are solved. We would also be giving you limited access video, limited validity videos, I would like to call it, which would be provided for your review and revision. And maybe if you miss some session, then we would be giving you these videos. But these videos would be typically available during the duration of the course, and then they would not be available. So you have to watch these videos during the uh, duration of the course. Okay. Then what we expect, that the expected outcome is that you should, after completion of this course, you should be able to understand the various systems that are used as lateral load resisting system in earthquake engineering. You should be able to calculate the earthquake load, and you should be able to calculate the load distribution for these earthquake effects. And then as a designer or as a participant, you should be able to design and detail a RCC building for earthquake loads manually also, and by using your ETAP software also. So we are looking at these outcomes after the end of this course. Okay. Then these are some general guidelines. So I think by now you, most of you have attended many online sessions, so you are aware of all these issues. So we would be conducting sessions on Zoom. This is, I think, understood. Then have a hard copy or soft copy of IS 1893 and IS 13920. Okay. So these we would be referring to, these two codes we would be referring to. So have a copy of it with you. We would not be giving you any printed notes sort of thing. If there is some solved example that is to be shared with you, or if some calculation has to be shared with you, that we will share. But daily notes of each and every lecture will not be given, because we are giving you the recorded videos. So we assume that you are taking notes on your own, and we would encourage that you are taking notes on your own. Okay. Uh, then I think most of the other things are now well known. So I will just uh, go through them quickly. So yes, so today is this introductory session. We would be starting our sessions from Thursday, that is 29th of October. Okay, and 8:30 a.m. 29th of October, Thursday, we would be starting our sessions. So we generally take the course fee in advance. So whoever needs to participate, or whoever is interested in attending this course, they should make this fee payment by 28th of October, and the fee that we have kept is 2,000 rupees. So this is the course fee that we have kept for the complete course. So we would request you to make this payment by 28th of October, and then we would be starting from 29th of October. Okay. So for the registered participants, we would be making a separate WhatsApp group where we would be sharing all the session links and session video recordings and all the other stuff. Uh, those who are in the present WhatsApp group, they also need not leave, because we generally share useful information from time to time, whatever general information we have. So that's it. I think our course we will start from 8:30 a.m. 29th of October, Thursday. Okay. So thank you for patiently listening to this complete discussion. And now we will take all your queries. And when I say all your queries, I mean all your queries, whatever your queries may be, one by one you can ask. Those queries may be related to the course or maybe on some issue related to earthquake design or any query that you have, you may ask. So now is the time. We would again like to thank you for patiently listening to this discussion. So Mr. Yogendra is asking how detailing will be covered using ETABS. Yes, so detailing, see, detailing, by detailing, I do not mean that the bar spacing and the bar dia, because generally those issues we like to cover it manually itself, because there are lots of decisions that are to be taken by a designer, which cannot be told to ETABS. Okay, so by detailing, I mean that ETABS will be giving us the reinforcement requirement, and then the bar sizes and bar spacing we would like to calculate on our own. Understood? Mr. Jigar is asking, will you be teaching beam column joint design? Yes. So in this new code, IS 13920-2016, they have introduced two major concepts that were not available earlier. So those two major concepts are, one is your beam column capacity ratio, that was not available in IS 13920 earlier. So this is one new concept that they have introduced, and they have introduced some ratio that has to be maintained. So this is actually a design aspect that has been introduced. And the second aspect that has been introduced is joint shear design. Uh, okay. So this joint shear is also a new concept that has been introduced, which affects your design of beam column. So these two aspects we would be covering during the course. So we would be solving these manually also, these two issues, and we also would be doing it on software. So ETABS 18 is able to do both these issues on software also. Your code does not give you very proper guidelines for manual calculations. Okay, so if you read IS 13920, there are no solved examples also, and it does not give you a proper method to calculate beam column capacity ratio and to calculate joint shear design. Okay, so in the absence of any proper method and in absence of solved example, it becomes really difficult for us to uh, be able to practically solve these two aspects. So in this course, we would be solving these manually also, which would be a very interesting thing. Okay. Vertical earthquake, I will give you some idea. What is the basic idea related to vertical earthquakes? I will give you. Mr. Rahul is asking, response spectrum will be covered. So I will give you a basic understanding of response spectrum, but we would not be trying to solve using response spectrum method. Okay. But I will give you a basic idea related to response spectrum. What is meant by response spectrum, that I will tell you. Okay. Yes. Any more questions we have? So ETABS 2017 is also, I think, updated for these two new revisions of IS code. But there are certain issues in ETABS 2017 that it does not perform analysis properly, or it does not. I think it gets corrupted after you perform your design. There is some technical bug in ETABS 2017. So I would not recommend you to use ETABS 2017. Use ETABS 2018. Okay. And ETABS 2016 is not updated for these two new revisions in IS code. So ETABS 2016 is not useful for us. So you should be using ETABS 2018. Okay. Mr. Sahil is asking clause 6.3.3 of IS 13920 pertaining to shear capacity of beam. 6.3, yeah, I have this code available ready with me. So 6.3.3. So we will just open 6.3.3. Yes, we will cover this. 6.3.3 we will cover, yes. We will cover this, which is calculating the shear on the basis of moment capacity. Okay, capacity design method which we use to calculate shear in our beams. So this we will cover. This is an important thing, and this was available in your earlier code also. So this we will cover during this session. Okay. Mr. Rahul is asking, is foundation design? Please tell us at least analysis result took which is taken for design. Please tell this. Yeah, okay. So I will tell you what results are to be taken for analysis. I mean, for further design, what results are to be taken, I will tell you. Okay, I will tell this. Miss Mohsin is asking, is it recommended that ETABS is open at the time of session? And what will be the duration of each class? So duration of each class will be, we will start at 8:30 and by around 10 a.m. that is morning, we would be finishing. So the duration would be around 90 minutes. And then we would be having a short discussion session of around 10 to 15 minutes. So that discussion session, doubt solving session is optional. I mean, who is not having doubts, they may leave, they may choose to attend on as per their wish. So is it recommended that ETABS is open at the time of session? Yes. So I would suggest one thing, that you may, some days we would be discussing things on board. Okay. So during those days, you do not require ETABS as such open with you. And during some days, we would be discussing things on ETABS itself. So I would say, when we are having session on ETABS, what you can do, that you can log in through your mobile. Okay. You can watch the session through your mobile. And then parallelly you can work on your ETABS. So in this way you would be able to watch the video also, what we are what we are teaching, and parallelly you can practice it on ETABS also. But you also have this facility of recorded video. So let's say, even if you choose to just watch the session on ETABS, and maybe you can practice it later on watching the recorded video. So this flexibility you have. Mr. Yogendra is asking, shear wall design and detailing manually or ETABS? Yes, so shear wall design, ETABS is able to do. So ETABS is able to do your boundary wall design also, boundary element design also. And ETABS is able to design for uniform reinforcement also. So basically there are two design methods of shear wall. That one is, we use the boundary element concept. So ETABS is able to do your boundary element concept also, and ETABS is also able to do your uniform reinforcement design. So we would be discussing both. Stiffness modifiers, yes, I would be telling you what is meant by stiffness modifiers. I will be telling you. Manually, manually, I would introduce you how manual shear wall design needs to be done. I will make you understand. There are basically procedure given in IS 13920 for the manual design of shear wall having uniform reinforcement. So I will be telling you that procedure. Mr. Jigar is asking about the model analysis. So I tried to I tried to answer this question earlier also, that I would be introducing you what is meant by mode and what is meant by mode shapes, but we would not be covering response spectrum method as such. So I think by model analysis you mean about the response spectrum method. So I would introduce you what is the response spectrum method, but we would not be solving the response spectrum method over here. Okay. Okay. Yes. Any more questions we have? Okay, Mr. Yogendra is saying, at least demonstrate how to apply response spectrum in ETABS. Okay, I will tell you. I will tell you how response spectrum method is to be applied in ETABS. But that I will introduce that method, how it is to be done in ETABS. Okay. Because see, what I would like to believe that as a designer, you should be more focusing on the design and detailing aspect. Actually, what happens in your post-graduation studies and during your engineering studies, that you focus more on the analysis part. And as I told you, your general buildings, what we have, your general buildings can be worked out pretty well with your equivalent static method of earthquake load calculation, which I would be discussing. So your general buildings can be designed or can be analyzed as per your equivalent static method. So analysis part in many cases can be done by equivalent static, but during our learning in colleges, we focus more on the analysis part, and we sometimes tend to neglect the design and detailing part. Okay, but for the practical engineer, the design and detailing part is also very important, which generally is not properly discussed during your curriculum. Okay, so I would also see. So I would like to focus more on design and detailing part, which is an actual thing that you would be doing in your project, rather than focusing more on the analysis part. Okay. All right. Yes. Any more questions we have? Yes, Mr. Arvind is having. Please share the online payment link to join the class. I don't have ETABS. SAP 2000. Okay, I will share a link from which you can download ETABS 2018. So I will share that link for downloading ETABS 2018. Okay. Yes, after this session is completed, I will share a response form, and I will also share you the details through which you can make the fee payment if you want to join this course. I will do that. Yes. Any more questions? Okay. So I think this is it. Then there are no more questions. So yes, Mr. Soham is asking. Actual build, yes, we would be taking an actual building also. We would be taking an actual building also in the end, and we would be trying to do the complete design and detailing part uh, on the actual building as well. Okay, so Mr. Arvind is thanking for taking the session, useful and informative. Okay, so thank you everyone. So I am really looking forward to this course. We have not taken such a course in the past, but all these things related to earthquake design and detailing are very interesting personally to me, because personally we have studied a lot of aspects related to earthquake design, and we have also used a lot of aspects related to earthquake design in our projects. So personally, this entire thing is pretty, I would say it is of great interest to me personally. So I'm really looking forward to this course, and we would be conducting it in such a way that uh, you are able to have some tangible outputs after the session. Okay, after the completion of this course, you would feel that you have learned some actual useful and new things. So we would be trying to cover in this way. Yes, Mr. Jigar is asking, is the draft useful made by IIT professors? Yes, I also, I came to know this, that a solved example draft has been currently prepared. I have not seen it myself, but if you have that draft, please share with me, Mr. Jigar. Yes, please share it with me also. Okay, Mr. Yogendra also has. Yes, so anyone who has, they may share it with me. Mr. Rahul is asking, please share an example with flat slab with shear wall. So that would be difficult to take over here, because in itself that will imply lots of new things that have to be told to you related to flat slabs. So flat slabs I will not try to cover over here. Okay. Okay. Any more questions that we have? Okay, so Mr. Yogate has also tried to validate few examples by STAT on the basis of those solved example for IS 13920. So as I told you, STAT is also able to do these things properly. The only issue for STAT is that STAT is not able to take STAT is not able to make calculations for the beam column capacity ratio and for the joint shear design, because these two concepts were introduced in 2016 code itself. So STAT is not able to do this. Rest, other than that, STAT is able to do the normal capacity based design on all the clauses that were there in the previous revision of IS 13920. Okay. Yes. Mr. Rahul is saying, please take an example with flat slab with shear wall. So that's what I told you. We would not be taking an example of flat slab with shear wall because it will involve lots of discussion related to flat slab also. So you need to have some basic understanding of flat slab for to be able to understand issues related to flat slab plus shear wall. So we would not be taking flat slab plus shear wall. We would be taking your general building with shear wall, with and without shear wall. Okay. All right. Any more questions? Yes. Mr. Aman is saying, please explain design of foundation. So design of foundation, as I told you, design of foundation in itself needs understanding of many other issues. So design part of foundation we will not cover. But I will tell you about the detailing things that you need to keep in mind. Okay. So foundation detailing, I will tell you how reinforcement needs to be placed. Some detailing aspects that are given in IS 13920 that I will tell you. But design part would be difficult to cover in such a short duration of this course that we have. Okay. Seismic dampers, Mr. Arvind is asking, we would not be covering seismic dampers because those are not practically used in India as of now. They are, some basic use has been started, but they are not being extensively used. So seismic dampers we would not be covering. RCDC for detailing. Yes, RCDC I think can be used for detailing. So detailing part, when I say detailing, I mean that area of steel is being calculated by your software, and then you can just take that area of steel and you can try to find out the reinforcement spacing and bar dia on your own. Okay, so when I say detailing, I mean to say that area of steel is taken as an input from your software, and then the bar dia and bar spacing and all those things you can calculate on your own. And personally, we like to calculate it on our own because of lots of site issues and lots of site strategies, lots of site decisions that are involved in uh, the detailing aspect. So personally, we like to have this detailing done by our own. Okay. All right. Shear wall length calculation will we do? Mr. Sohail is asking. So I will try to tell you how this can be done. I will try to introduce this concept to you. Okay. Any other question that we have? No, we will not take steel building in this because steel building, actually the ductile detailing of steel building is not very clearly covered by IS code as such. So ductile detailing of steel building, there is no separate code. There is a special publication number 6 to cover certain issues related to ductile design and detailing of seismic frame. seismic resisting frame, I would like to call it. But not many things are clearly mentioned in your Indian codes for ductile designing of your steel frame. Okay, so it becomes really difficult to understand. So we would not be covering any aspect related to steel buildings in this course. Mr. Jigar is asking time period calculation. Yes, of course, time period calculation has to be covered, because without time period, you won't be able to calculate your earthquake loads. So time period calculations you would be obviously covering. Okay. Right. Any more questions? Mr. Arvind is asking about the difference in ETABS and SAP. So difference, see, ETAB, SAP is a general purpose software structural analysis program. Okay, so SAP is a general purpose analysis and design software. Out of this SAP, I mean the company, the developer company is same for these two softwares, which is CSI, Computers and Structures Incorporate. So the company is same. These are just the two different products of the same company. So structural analysis program SAP is a general purpose software for analysis and design. Okay. Then out of this general purpose software, they have uh, given some additional powers, and they have created a new software called as ETABS. So which is more effective for your building systems. Okay. So ETABS stands for Extended Tabulated Analysis for Building Systems, ETABS. Okay. And it has some additional powers which are useful in the case of building design. By building, I mean where you have regular stories, your stories are similar to one another, and uh, it consists of some horizontal elements and some vertical elements. So your ETABS is more suitable for using in building designs. So the input, the modeling options, the output options, and some outputs related to design and detailing, those are more suited for your building design systems. So this is the basic difference between ETABS and SAP. Mr. Arthur is asking about CQC and SRSS. So as I told you, these two methods are methods to combine different modal responses in case of response spectrum method. So response spectrum method we will not be covering in much detail. I would be introducing to you the basics of response spectrum method, but we would not be covering it in much detail. Okay. So I will just tell you this concept behind CQC and SRSS. Yes, so that's what I was telling. There is some question related to response spectrum. So I will tell response spectrum on actual model, but we would not be going into much detail about that. Okay. Any other point? Okay, so I think that's it then. Thank you everyone. And I mean, both of us are really looking forward to start this course, because this is an interesting course which we feel would be of great benefit to practicing engineers and graduate students, undergraduate students, faculty members. So whoever is going to take this course, I personally think that this would be an interesting course for them. So both of us, I and Akanksha, are looking forward that all of you join this course and we have a good time together uh, when we start this. Okay, so that's it. And thank you everyone for patiently listening. Have a good day, and we will see you on Thursday, 29th of October. So till then, goodbye and take care. Bye bye.